fine. What period? After school or? That's fine. You know where I'll be though. In the closet.
You don't watch football. You can tell me I watch.
But yeah, that's totally fine. All right. So listen, y'all, I am recording your class because I'm gone tomorrow. So let's try to lock it in and make our video not too long for little fourth period. We're gonna start on number 2. Okay, so I believe we skipped this one last time. And then y'all hopefully did the video, or you might be a little lost last time, but we'll just do our best. Okay, so the first thing you're gonna do is your find, given, when. Okay, so number 2, find, given, and when. Now remember, number 2, yes, that your find and your given are going to be how fast certain things are changing. Okay, so it could be how fast a side is changing, area, length, blah, blah, blah. So look at number 2. It says we have a ball being inflated with air. How do you measure how much air is inside something? What quantity is that? Huh? Volume. Thank you. So you're going to put here under given that we know that the volume, or dVdt, is changing at a rate of 800. And then if it's cubic centimeters, that'd be centimeters cubed per minute. Yes. Just look for it. Your packet might be in a different order. Okay, then just don't write this one down. And the next one will get you. Okay, then it says, how fast is the radius changing? So we're trying to find dr dt. We want to know how fast the radius is changing. That would be dr dt. Okay, then it says at the instant when the radius is 40. Now keep in mind that the radius isn't always 40. Okay, but there's a moment as it's growing that it'll hit that moment. That's when we're going to like take the snapshot, if you will. Okay, so peek back one page to your little formula chart.
Here's this number 4.
Yeah, I knew it was in there. Okay, and then we're talking about a ball. So it's a sphere. So do you see the volume of a sphere formula right here? Okay, write it down. That's your equation. So it's 4/3 pi r cubed. Okay, then remember our next step is to take the derivative. Now, when we take the derivative, we're taking it with respect to time. So I want you to put a d dt. That means we're taking the derivative where t is our main letter. What's the derivative of b called? V would go to d dv dt. And then on the other side, I'm just going to do the power. So what is 3 times 4 divided by 3? But 12/3 would still be 4. So think about it. If you're timesing the 3, it's going to cross out with the 3 on bottom. You're just going to keep the 4. Okay, then I have to reduce the power by 1. So my pi r cubed is now a pi r squared. And then I remember that I have to attach a dr dt. That's for literally any letter that's not a t for time. Okay, from there we're plugging stuff in. So dv dt is an 800 centimeters cubed per minute, equal to 4 pi r is a 40 centimeters squared dr dt. Okay, then from there, I wish I'd made you get a calculator, but I didn't. Can we do 40 squared in our head? 40 times 40 would be 1600, and then if I times it by 4, it'd go to 6400. So write down 800 pi, or sorry, 800 centimeters cubed per minute. And then this is 1600 times 4 would go to 6400 pi. Okay, now let's talk about units for a second. My 40 was centimeters, but I squared it. So now it's squared centimeters times dr dt. And then if I'm trying to solve for this guy and it's multiplied with a 6400 pi, how do I get rid of that number? Divide it. So you're going to divide 6400 pi centimeters squared on both sides. Okay. And then these guys over here, they're going to cross out. So my dr dt is by itself. So I have dr dt equals, here goes my final answer. Okay, if you have an 800 over a 6400, you should kind of know this, but if I have 2 zeros on top and 2 zeros on bottom, I can just cross those out. So I'm going to get rid of these two and these two. And that means really it's just an 8 over 64. What is that the same as? They can both divide by 8. 1/8. And then don't forget that your pi here, since it's on the bottom, it should be a 1 over 8 pi. Okay, now let's talk about units for a second. I had cubic centimeters per minute, but I'm dividing centimeters squared out. So what would be left out of my centimeters cubed? Regular centimeters per minute. And now I want you to think about for a second, does it make sense that a radius changing would be measured in centimeters per minute? Okay, and the answer to that is yes. Okay, so I'll give you a little cliff notes in a second on your formula sheet. But if you're measuring how long something is, centimeters is great. Okay, or inches or feet. Centimeters squared would be area, cubed would be volume. Okay? All right, let's do part B. The only thing we're going to change is what we're finding. This time we want how fast the surface area is changing. So I'm going to call that dA dt. And then I want you to peek back at your formula chart. You do not have to memorize all of those. Okay, if they use them on the AP test, they'll put it in there. What is the area for a sphere? Uh-huh, 4 pi r squared. Okay, and make sure you're not on pi r squared because that's for a circle. We want a sphere. Okay, let's take the derivative. What's the derivative of a? dA dt, very good. And then on the 4 pi r squared, I do the 2 times by the 4 pi makes it an 8 pi. My r squared drops to a regular r. And then attach the dr dt. Then from there, we're just plugging in the crap that we already have. So I know that my radius is a 40. I'm going to go ahead and put the centimeters on here. And then my dr dt was a 1 over 8 pi. And that was centimeters per minute. Now, what's going to happen if I have a times 8 pi and a divide 8 pi? Cross those out. So my number is just going to end up being a 40 here. Okay, let's talk about our units. I have centimeters multiplied by centimeters per minute. What will happen to my centimeters? Centimeters squared per minute. And I want you to think about that if this is a dA dt, which is area, then square centimeters is perfect for that. Okay? All right, then will you turn back to your formula chart? I'm going to give you just a little cheat sheet on your formula chart for units. Okay, that usually for the rest of this packet, I'm not going to keep track of the units all the way through because you can just kind of know what they are at the end. So on your little cheat sheet here with all the formulas, okay, if it is a measurement, your units are going to be unit per time. So if it's like a length or a height or a base or a radius, units per time is how it should come out. If it's an area, it would be units squared per time. And then if it's a volume, we said it's units cubed per time. Okay. So hopefully that kind of helps. As far as the homework, this really doesn't matter because it's not going to ask you. But for the AP test, sometimes if it's like a free response, they'll make you put units. Okay. All right, we're not doing this whole packet, but we're going to do a couple more. So the next one that we're going to do, please, is number 6. Will you turn ahead to number 6? Okay, you have a very ugly baseball diamond drawn by me. Okay, so it says we have a baseball diamond. It's the shape of a square with a 90-foot baseline. Now, I want you to label the baseline with a 90 because that's not something that's changing. Okay, how long the distance is between the bases, that's fixed. Okay, so after you put the 90 there, I want you to mark it all the way around the triangle, or sorry, the square, because since it does say it's a square, we know all the sides are 90. Okay, then it says we have a player. You can look at, there he is, perfectly drawn. Okay, and it says that he's running from, oh, he should be running towards third base. I don't know baseball, just pretend. Okay, and it says he's running at 28 feet per second. At what rate is his distance from home plate changing? So you're going to highlight this triangle right here. He's running towards third base. We're measuring how far away he is from home base. And then we know that the distance he'll have to run next is 90. So you have a nice little geometric shape of a triangle. Okay, let's label now what the sides of the triangle that are changing should be. So I'm going to call this side X. And that's going to be how far away he is from this base, because we know he's running that way towards third base. Okay, then for your player's distance from home, okay, I'm going to call that H for home, because sometimes my S's start looking like 5s and it makes it confusing. So let's change our S to an H for home plate. Okay? Or if you like H for hypotenuse, that's fine too. All right, so let's do our find, give, and when. Okay, we are trying to find at what rate the player's distance from home is changing. What are we finding? D, what letter, DT? H. So we want DH, DT, but we're given how fast he's running. It says he's 48 feet away and he's running at a speed of 28 feet per second. So I'm going to put that dx dt is 28. Now, quick clarification here. 28 means that the length of that triangle is increasing 28 feet per second. If he's running towards third base, does that make sense? What's going to happen to how far this is? It's going to shrink. So the 28 really needs to be negative. Because as he's running closer to third base, that side's going to shrink. Okay, then my when is that he's 48 feet away. So my X is 48. Okay, now look back on your little cheat sheet of all your formulas. And I want you to think about which formula would relate the X and the H sides for our triangle. And I'm gonna get you kind of. So look back at them. Okay, you know it's a triangle. Not area, because we want all three sides. Not perimeter. Pythagorean theorem. Remember a squared plus b squared is c squared? Yes. Okay, so on your sheet, I want you to write the Pythagorean theorem. It'd be x squared plus 90 squared equals h squared. Okay, once you've written that down, I want you to take the derivative. So the three sides of a right triangle, we're going to use Pythagorean theorem for that. So like we said, our equation is x squared plus 90 squared equals h squared. What would the derivative be? 2x what? Dx dt. Now 90 is a constant. So what's the derivative of a constant if it has no number with it? It'll go to 0 because it's a constant. Okay, then my h squared is going to go to a 2h dh dt. Okay, now we're ready to plug in. So 2 times x is 48. Dx dt is a negative 28. Equal to 2 times h and then dh dt. Now we run into a little problem that when I get to the h part, I don't have a number for that because I don't know how far away he is from home plate. But I want you to think about if I know he's 48 feet away and I know that this side is 90, then can I find what this third side would have to be? Yeah, and you'll use Pythagorean theorem, but before you took the derivative of it. So we'll do a little side work here. 48 squared plus 90 squared equals h squared. And then once we know h, we can plug it into that last open space and then solve. And it should be a whole number, I think. Okay, so we got 10,404. And then square root of that is 102. So now I have a value to plug in to this spot. Okay, and that will come up that here and there, you'll have like a number that like, oops, I didn't know I was gonna need this, that you'll just have to go back and find it. Okay, from there, let's solve for our dH dt. We're gonna do 2 times 48 times negative 28. That gives me negative 2688. 2 times 102 gives me 204 dH dt. And then to solve for dH dt, all we have to do is divide that 204 out of the way. Now, I'm pretty sure for your homework, it tells you to round to the nearest thousandth. So that would be 3 decimal places. So we're doing this, divide by this. So your dH dt, the distance from home plate, is changing at 176. Okay, now let's think about units for a second. Okay, if I'm measuring how far away he is from home plate, will it be feet, feet squared, or feet cubed? Regular feet, very good. So it'd be feet per second. And that way you don't have to like keep track of the units the whole way. You can just kind of think about it at the end. Okay. All right, we are going to do number 7 at the bottom of this one. So it says we have a sand and gravel plant. Sand is falling off a belt into a conical pile. Okay, for the AP test, usually they'll draw the picture for you. But I just forgot to draw it for this one. So draw yourself a little pile shaped like a cone. Okay, so we're gonna do circle on the bottom. And then somehow it's falling onto the pile to make a perfect cone. Okay, then find, given, and when. Okay, it says that at the plant, the sand is falling off onto the belt, making the pile. And it says it's 10 cubic feet per minute. What is that a measurement of? Cubic feet per minute. Volume, very good. So my given is dVdt, and it's equal to 10. Okay, then it says the diameter of the base is 3 times the altitude. Okay, I'm just gonna write that over here because that really doesn't seem to go with the question. Diameter is 3 times the altitude. Let's just write it down and then we'll keep reading. At what rate is the height of the pile changing? What are we finding? Height, dH dt. And then it says when it is 15 feet high. So I want my h to be 15. Okay, look at your little sheet of formulas. This is a cone. And we want volume of a cone. Volume of a cone. So right here. Do right there. 1/3 pi r squared h. Okay, right there. 1/3 pi r squared h. Okay, now if you took the derivative of this right now, you would need product rule, and here's why. You have r stuff times h stuff. So this needs product rule the way that it's written right now. Now, there's one issue with me trying to do product rule. And the issue is that I know stuff about V. I want to know stuff about H, but R is not even like in the rest of the problem. So what we're going to do is we're going to come back to this. Okay, we know that the diameter is 3 times the altitude. The diameter is how far across the bottom of the circle. The full length. And how far is the radius? Half. So if this is my radius, how many radius would it take to make a diameter? 2 of them. So put 2r. And then 3 times the altitude is the same as 3 times the height. Okay, altitude and height are the exact same thing. It's just a different way to say it. So what I'm going to do is I'm going to solve this for r so that I can take r out of this equation and then not need product rule anymore. It'll just make our lives easier. So what would I have to do here to get r alone? Divide by 2. So I know that my r is really equal to 3 times the height divided by 2. And then I'm going to use that substitution to eliminate r from my equation. So that way it'll only be h's and I won't need a product rule anymore. So V equals 1/3 pi r squared h. And then in the r position, I'm going to put this little guy, the 3/2 h. Okay, let's do the number part first. What is 3/2 if you square it? Because we have to square both of these guys. So square the top and the bottom. Close to 3 times 3. 9, yes, over 4. And then remember, the h is going to get squared too. But the h after I square it has to times by 1 more h. So how many h's am I going to have altogether? 3. Okay, then let's clean this little fraction up here. Remember, fractions, you times the tops and the bottoms together. So 1 times 9 is going to stay a 9. And then 3 times 4 is going to be a 12. Now, if you want to reduce that, you can, but I'm not going to. I'm just going to leave it. So let's take the derivative. What is the derivative of v going to be called? dv dt. And then the derivative of the 9 pi over 12h cubed. 3 will times down on the 9 pi. What's that now? 27 pi over 12. Okay, and I could reduce it, but I just don't want to. It's fine. Okay, and then my h cubed is going to drop to an h squared, because I have to reduce the power by 1, dh dt. And then now from here, I'm ready to plug my numbers in. So let's do it. I'm going to do it right here. So now we're plugging in. I know my dv/dt. What's the answer for that? 10. So 10 equals. Okay, 27 pi over 12 is just going to stay there for now. And then my h is what? They gave us a number for that. 15 squared. And then dh dt. Okay, I'm going to type this entire side into the calculator. But I'm not going to do the pi. I'm going to leave the pi out so that I can have like a clean fraction instead of a decimal. So it'll be 27 over 12 times 15 squared. So that comes out to 2025 over 4. So I have 10 equals 2025 pi over 4 times dh dt. If I'm trying to cross this fraction out to solve for dh dt, you're going to multiply the reciprocal on both sides to cross it out. So think about, like, I want to get rid of a divide by 4. Well, then I'm going to multiply the 4 across. And then if I want to get rid of a 2025 pi multiplication, I would divide that across. But if you want to just think about it as like a reciprocal on the fraction, that also would work. Okay. Then in the calculator, let's see what that would be. 4 over 2025 times 10 would be 8 over 405, and then just keep your pi at the bottom. So that'd be 8 over 405 pi equal to dh dt. Okay. Now for your homework, I think I told you it asks you to round. Okay, tell me what is wrong with how I'm typing this in, because a lot of people have needed resets for this. Is this fine? No. Okay, here's why not. You have to divide by the entire 405 pi. That is the same as what I have. Do you see the difference? Okay, so make sure if you're dividing by more than one thing, you have to group, or you can pretty fraction and do 8 over 405 pi, and then you don't have to use the parentheses. Okay, but the first one of these is wrong. Delta math won't count it correct. Okay, but that would be correct. So if you want to write for your homework, it'd be 0.006 for that answer. Okay? But I kind of ran out of it, so I'm going to do. All right, next one we're going to do, will you turn ahead to number 10? Okay, we're doing only 3 more left because I know these take forever. Okay, so turn to number 10. Okay, number 10 says that you have a snowball with a radius of 70 And it says it's melting and its radius is decreasing at a rate of 2 centimeters per minute. So find given when equation. Okay, so the first thing that I notice is this sentence right here. It tells me the radius is decreasing at a constant rate of 2 centimeters per minute. So I'm given dr dt and it's equal to 2. Now, what that means is that my radius is increasing 2 centimeters per minute. Is that correct? If it's melting, what's happening to my radius? Decreasing. So I have to put a negative on my 2. Because my radius isn't growing, it's shrinking, right? Okay, then it says, how fast is the volume decreasing? So we're trying to find dv dt. And then my when, this is kind of a weird one, but it says half an hour later. So I'm going to put here half hour later question mark. Now it says that the initial snowball before it started melting was how big of a radius? 70. So I'm going to put the starting radius was 70. But then I don't want that time. I want half an hour later after that. So let's pull our equation. We know that our snowball is a sphere. Okay, and we already did the volume of that earlier. It was 4/3 pi r cubed. We also already took the derivative of that. So obviously you're welcome to do it again if you want to, but it was 4 pi r squared dr dt. So we're a little bit stealing work from the balloon problem, but it's fine. Okay, what measurement am I going to need to find dv dt if I only so far have dr dt? I need to know what else. So I want this one. I have this one. What do I still need? I know dr dt, it's -2. I need regular r, right? And I know that the radius at the beginning was 70, but I don't know what it is later. So let's think about this. I'm going to walk you through it. The starting radius is 70. It's going to go down 2 centimeters each minute. How many minutes will go by in half an hour? 30 minutes. So if it goes down 2 centimeters each minute for 30 minutes, how much is it going to go down? 60. And it started at what amount? 70. So if it started at 70 and it's going to go down 60, what's my radius 30 minutes later? 10. So I'm going to put here that my R would have to be 10. And now I have everything that I need that I can plug in. So my dv dt equals 4 pi. My R is a 10. My dr dt is a -2. Then what's 10 squared? 100. 100 times 4 pi would be 400 pi. Then times -2 would be -800 pi. Then if this is a measurement for volume, would it be centimeters, square centimeters, or cubic centimeters? Cubic. And then per minute is what time is measured in. Okay. Another thing just to kind of think about is that why did the rate come out negative? Because overall, what's happening to the volume of the snowball as it melts? It's decreasing. So a negative means that thing is shrinking versus a positive would mean that thing is growing. Okay? All right, turn the page. We're doing just one more instead of 2. I said 2, but I'll change it to 1. Go to the trig question. Okay, this is your last one for today. And then you'll have time to work on your homework. Okay, in order to do the last question, okay, you have to remember SOHCAHTOA from pre-cal. And I know that some of you may not, but let's do a little recap. Okay, so is sine, and sine is O over H. Cosine is ca, and it's A over H. And then tan is TOA, which is O over A. Michael, this is our last one. Can you do it? Come on, just one more. One more. Okay, the O, the A, and the H stand for the different sides on the triangle. So H is hypotenuse. Can you tell me on this triangle which one is the hypotenuse? Which one? The longest side, or the 13. So I'm going to put hypotenuse. Okay, remember that the hypotenuse is the longest side opposite the right angle. Okay, out of the remaining two sides, you have your theta here. Okay, the opposite side should be across from or not touching your theta. So my opposite side is here, which means that my adjacent side is here. Now, if they only give you two sides, that's actually not a problem because we know Pythagorean theorem. So can you find the missing side? It should be a whole number. So we do 12 squared plus, let's just call this x for now. 12 squared plus x squared equals 13 squared, and we're just going to find whatever that third side is. Now, in the calculator, should I add the 12 squared and the 13 squared? If they're on opposite sides, you should really subtract them. Yeah. So it'll be x squared equals 25. Then square root, your missing side length is 5. Okay, once you have all three sides, to find sine, cosine, and tangent, all that you have to do is pick the SO, CA, or TOA ratio. So over here to the side, put sine theta equals, cosine theta equals, and tan theta equals. If sine is O over H, what numbers would that be from my triangle? So O over H for sine. 5/13. So that's the answer. Very good. Okay, for cosine, I want A over H because it's ca, so that would be 12 over 13. And then your last one would be tan, which is O over A, so it'd be 5 over 12. Okay. Then there are actually 3 more trig functions. You have all your flippies of the originals. So sines flipped is CSC. And that would be 13 over 5. Because remember, CSC is just sine flipped. So instead of O over H, it's H over O. Cosines flip is SEC, and it'd be 13 over 12. And then tan would go to cotan, and it'd be 12 over 5. Okay? So just a little recap on that, and then we're going to do example 13, which is going to have a trig in it. So find the missing side using Pythagorean theorem, label your O, H, and your A, and then do whichever SOHCAHTOA you need. So let's do number 13, last one, you can do it. It says, a fish is reeled in at a rate of 2 feet per second from a bridge that is 16 feet above the water. At what rate is the angle between the line and the water changing when there's 20 feet of line out? So draw yourself a bridge. And you're on the bridge. Here you are. Okay, and you have a fishing pole. And you're trying to get this little fishy over here. Okay. So you have bridge, fishing line, and then fish. Okay, I want you to draw a little triangle. Okay, we're gonna do the fishing line here, the height of the bridge, and then how far away the fish is. So you made a right triangle. Okay, now let's label some stuff. So the first thing I notice is how tall the bridge is. How tall does it say the bridge is above the water? Is that something that's changing or is that fixed? Fixed. So my 16 feet above the water for the bridge, that is how long this side is 16. So I don't have to pick a letter if it's something that's not changing. Okay, then I have fishing line. So let's call that this side. And then for the other side, I'm just gonna pick an X because I don't, or we'll put W maybe for one. So fishing line and water. Okay, find given when. Okay, so it says the fish is reeled in at a rate of 2 feet per second. That means that my DLDT is equal to 2. Do I need to change anything? I'm reeling the fish in, so what's happening to the line? It's decreasing, so I need a negative. Very good. Okay, so my amount of fishing line as I reel the fish in is shrinking. Okay, next thing says, at what rate is the angle between the line and the water? So draw a theta here. And we want to know how fast that's changing. We're finding d theta dt. Okay, then it says that magic word when. There are 20 feet of line out, so my line needs to be 20. Okay, for my equation, I have to pick a SOHCAHTOA. And the reason why is that I want to relate this angle to these sides. Now, which letter has to be in my thing that I know stuff about? I have to pick L. And then if I know stuff about W, I can pick it, but they didn't really tell me anything. Do I know the other side? So these are my guys that I want to include. Which function will have a 16 and an L in it if this is my theta? Do I want SO, CA, or TOA? So is going to be correct. Let's label it. This is the opposite side. This is the hypotenuse. Okay, and then your water line, that would be your adjacent side. So if I want to have the opposite and the hypotenuse in it, that means the equation that I'm going to use is going to be sine. Okay? So right here, put equation equals sine theta equal to opposite over hypotenuse is 16 over L. Because remember, my hypotenuse is the fishing line or the L side. Okay, my next step is to take the derivative. What's the derivative of sine theta? Cosine theta. And then what do I have to put at the end? D theta dt. Because I took the derivative of something that was a variable other than a t for time. Now, for the 16 over L, nobody likes quotient rule, right? So if you can avoid it with a rewrite. How can I just pull this L up so that I don't have to do quotient rule? L to the -1. So I'm going to put rewrite. That's really 16L to the -1. Okay, because you could do quotient rule, okay, but that's going to take you way longer than just pulling the L up. So take the derivative, -1 times 16, what do I get? -16, and then what's my new power on L? -2, and then dl dt. Okay, before I plug in, I'm going to drop my L to the -2 back down to the bottom. So it'll be cosine theta, d theta dt equals negative 16 over L squared dl dt. And then at this point, I'm ready to plug stuff in. So I picked my sine function, I took the derivative with the rewrite. Now we're gonna plug stuff in. Okay, let's do that over here. So now we're gonna plug stuff in. Okay, for my cosine, I'm gonna use SO, CA, or TOA. Which one would cosine be? CA, very good. And so which sides would I use for cosine? I want the adjacent and the hypotenuse. Now, I know the hypotenuse, but I don't know the adjacent. Can I find it? Yeah, if this is 16 and I know my L is a 20, then can I know what my adjacent is to plug into my cosine? So do a little quick Pythagorean theorem. It would be 16 squared plus W squared equals 20 squared. And then remember, if I have opposite side numbers, I'm subtracting those and taking the square root. So 20 squared, take away 16 squared is 144. What's my missing side? 12. Okay. So let's plug into cosine. Cosine is going to be A over H. I'm going to rewrite this. Okay, let's plug in. My cosine is going to be A over H, which is a 12 over 20. My d theta dt, I don't know what that is, but I'm expecting that because that's what I'm trying to solve for. What is my L squared for me to put under the 16? We know what L is. What's L? 20. And then my dl dt is negative 2. Then from there, type this side into the calculator. Just use the pretty fraction to make it easy on yourself. So negative 16 over 20 squared times negative 2. And then if that's equal to 12 over 20 d theta dt, how can I get rid of the 12 over 20? Because I'm trying to get d theta dt by itself. Divide by, which means really multiply by the reciprocal. So I have 12 over 20 d theta dt equals 2 over 25. And then to cross this fraction out, I'm going to times both sides by 20 over 12. So my d theta dt is going to be 2 over 25 times 20 over 12. And it's 2/15 for your final answer. Now let's talk about units. This is how fast an angle is changing. So that would be radians per second. Okay. And then I will say that for the AP test, they've put angles on there before, but it's not very often. So if you can do the simple shapes, rectangles, triangles, circles, spheres, then 90% of the time that's good enough. Okay? All right, so you don't have a new homework. It's the same homework as last time. Okay, so next class, we're reviewing on Monday, and then you guys will take your unit test on Wednesday. Okay? All right. Good job.
Good luck, fourth period. Have a great weekend. Bye.